Hello everyone, welcome to the video lecture on histogram modeling. In this session, we are going to study about the histogram equalization. In previous session, we have seen the linear stretching. So, what we have seen that in case of linear stretching, if it is our original histogram, this is our original histogram, then in case of linear stretching, the gray level of that original histogram is stretched. Okay, that means all the range of gray level can be covered in case of histogram or linear stretching. Is histogram stretching. But the main limitation of this histogram stretching is that shape remains same. This is the main drawback of this histogram stretching, and there are several applications where we require the flat histogram. Flat histogram means the number of pixels present from gray level 0 to maximum gray level, that number of gray levels should have equal number of pixels. Such type of flat histograms are required in many applications, and that's why a new technique of histogram is developed, that is called as histogram equalization. So in this histogram equalization, what happens here, this type of histogram can be converted in such a way that each gray level should be having equal number of pixels. So this is called as ideal histogram or ideal histogram equalization. So the main aim in histogram equalization is spread dynamic range and along with this we have to also make equal pixels in each gray level. So the main aim is not only to spread the dynamic range of the image, but we have to also improve the number of pixels in each gray level or make equal number of pixels in each gray level. So this is our main aim of histogram equalization. Now directly we'll solve one numerical based on the histogram equalization. So example, equalize the given image. So let's consider the number of gray levels are given. So number of gray level, and or instead of saying number of gray level, we'll call it as only gray level. And number of pixels. So it is 0, 1, 2, 3, 4, 5, 6 and 7. So total number of pixels are suppose 790, then 1023, then 850, after that 656, after that 329, then 240, 245, then 122 and 81. So this is our given table. So here first of all we have to identify the number of gray levels. So let's consider L is nothing but number of gray levels. So here we can observe there are gray levels varying from 0 to 7. So L is equal to 8. This is nothing but number of gray levels. Okay, so first of all we have to plot the original histogram by using this particular table, and then we have to equalize the histogram. So here we have to make one more table, gray level, then here the number of pixels that are nothing but nk. After that we have to find out the PDF function. After that we have to also find out the CDF function. Likewise we want the table, so accordingly I'll create the table here. Like this. Okay, so we are having gray levels as 0, 1, 2, 3, 4, 5, 6 and 7. Number of pixels we are having 790, then 1023, 850, after that 656, 329, 245, 122 and 81. So the total number of pixels, that is nothing but total number of pixels, capital N, is nothing but the addition of all these pixels. So if we add all these pixels, the total addition is 4096. So total number of pixels present in our image are 4096. Then we have to find out the PDF function. So the formula of PDF function is PRRK is equal to NK upon N. So we can calculate PRRK is equal to NK upon N. So for probability of 0th gray level, we can calculate by number of pixels of that gray level divided by total number of pixels. So here I'll write down first, it will be calculated as 790 divided by 4096. Okay, likewise we can calculate this, and the final answer I'll write down here. So final value we are having equals to 0.19. Like that we have to calculate for this 1023, it is 0.25. then next one we are getting is 0.21. then for this we are having 0.16, then it is 0.08. for this one we are having 0.06. then for this value we are having 0.03, and for this 81 we are having 0.02. So these are the PDF values for this given image. Then we have to calculate the CDF. So that CDF can be calculated as SK is equal to summation of PRRK. That means for first value we are having only one value, so we'll write down it as it is 0.19. Now for the second value we have to add these two values. What we have to do, we have to add these two values and we have to write down the addition here. So 0.19 plus 0.25 is equal to 0.44. so the answer is 0.44. now for this third value, what you can do, you have to add the first three values and you have to write down the result of addition at the fourth place. or simply what you can do, you can add the first and second value and write down the answer here. So it will be 0.65. For this you can add these three values along with this value, so it will be 0.81. For this, the addition, that is 0.81 plus this 0.08, so it will be 0.89. For next value 0.89 plus this 0.06, so it will be 0.95. Then for this one 0.95 plus this 0.03, it will be 0.98, and for this 0.98 plus 0.02 will be equals to 1.0. So in case of histogram equalization, the CDF or the maximum value we are getting for CDF is always equal to 1. After this, here we have to write down L minus 1 into SK. So in previous slide we have seen the L is equal to 8. Okay, so L minus 1 will be 7 into SK. So first value is calculated as 7 into 0.19. Okay, so 7 into 0.19, we are getting the answer as 1.33. Similarly 0.45 into 7, it is 3.06. 0.65 into 7, 4.55. 0.81 into 7, it is 5.67. After that, here it is getting 6.23. Next one 6.65. Next one is 6.86, and here finally we are getting the value equals to 6. In last column we have to round off the previous column. So 1.33 will be equals to 1, 3.66 will be equals to 3, 4.5 will round up to 5, 5.6 will round up to 6, 6.2 will be round up to 6, and 6.6, 6.8 are round up to 7. So this is our final rounded table. Now what we'll do, we'll take the first, second and the last column from this table. So first, second and last column we have to consider, and then we have to find out the number of pixels. So here I have made, or I have selected the 3 columns from this and created the new table like this. So for old gray level 0, our new gray level we are getting is 1. Likewise for gray level 1 we are having new gray level 3. For gray level 2 we are having new gray level 5. For gray level 3 we are having new gray level 6, and for gray level 4 we are having new gray level 6. So what we have to do, we have to add these two values and we have to assign that to gray level 6. Similarly for gray level 7 we have to add these 3 values of pixels and we have to assign that to gray level 7. So here we can one more table we can form as equalized gray level and number of pixels. So equalized gray level and number of pixels, such type of one more table we can form. Like this. So for gray level 0 we have no new gray level, so the number of pixels we have to assign are 0. For gray level 1 we are having old gray level equals to 0, and for that we are having total 790 pixel, so we have to assign here 790 pixel to gray level 1. Then for gray level 2, here no gray level 2 is available in this new gray level, so it will be 0. Gray level 3 is available here. How many pixels we have to assign for that gray level 3? That are 10, 23. Gray level 4 is absent here, so we'll assign 0 value. For gray level 5 we have to assign 850 number of pixels. So for gray level 5, 850 number of pixels we have to assign. For gray level 6, that gray level 6 is available here, and for that we have to add these two values of pixels, and that we have to write down here. So it will be 656 plus 329, which is equal to 985. So for gray level 6 we are having total 985 pixels, and for gray level 7 here it is available, and for that we have to add these 3 pixel values, which are 245 plus 122 plus 81, which will be equal to 448. So by this way here we can find out the new table for our equalized histogram, and then finally we have to draw the original histogram and equalized histogram like this. Zero, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2. So this is S and NK. This is NK and R. This one is its new histogram, or we can say equalized histogram. So for original gray level, for 0 we are having total 790 pixels. For gray level 1 we are having 1023 pixels. For gray level 2 we are having 850 pixels. Likewise we have to draw the original gray level. Here it is 1023, 850, 656, it is 329, 245, 122 and 81. And here for new case, in case of new histogram or equalized histogram, we have to refer this particular table, and accordingly we have to assign the number of pixels. So for gray level 0, 2 and 4 we are having 0 number of pixels. So for gray level 0, 0 pixels. For gray level 2, 0 pixels. And for gray level 4 we are having 0 number of pixels. Okay, and for rest of the pixels we have to assign the values. For gray level 1 we are having now 790 pixels. For gray level 3 we are having 23 pixels. For gray level 5 we are having 850 pixels. For gray level 6 we are having 985 pixels. And for gray level 7 we are having 448 pixels. So it is 790, 1023, 850, 985 and 448. So this is our original histogram, and this one is our new or equalized histogram. So by this way we can convert our original histogram into the equalized histogram. So thank you for watching the video.